You might notice that this video is not called Converting Irrationals. Converting Irrationals is a long procedure that works very well to get an actual value of a square root or cube root or similar root of irrationals by hand. However, it's quite simply, it's outdated. It works very well. There's no reason not to learn it. But at the same time, well, there is a reason not to learn it. You're watching this on some sort of a device, and I'm sure that device has the ability to take square roots and cube roots. Devices are just not very far from us anymore. So with that in mind, let me show you some techniques for estimating irrationals that you might actually use. If you ever want to learn how to convert an irrational, by all means, look it up and learn it. But estimating will do the job in almost every case. So with that in mind, let's look at a square root of 13. Now this is an irrational number because 13 is not a perfect square. So ideally for me, I would like to come up with a strategy that is faster than grabbing a calculator or switching apps on my phone. Now that may not actually be the case, but let me show you some options should you need to do this without a device. Okay, option number one is going to be, at its heart, the most basic, and math teachers for sure might bristle at this, but once again, we're estimating here. So don't hold me to the exact value that you're going to get. This will work pretty well to get you an estimate. With that said, here we go. The square root of 13 is between, well, what two perfect squares? Well, it's the lowest one is 9, and the highest one is 16. And 9 is a 3, and the square root of 16 is a 4. So our answer is going to be somewhere in between 3 and 4, which means it's 3 point something. I'm already halfway there, right? I already know what my value is, and I just need to fill in a decimal point or two. Now to do that, I'm going to write the whole numbers between 9 and 16. Now, in our basic estimate, I'm going to suggest that those numbers represent all of the values from 3.0 up to approximately 3.9, with the square root of 16 being 4. So now I'm going to go ahead and estimate where the center is. Well, I have 1, 2, 3 of them on one side and 1, 2, 3 of them on the other, so that means that this is about the middle. That means that if I had the square root of 12.5, which is halfway in between 12 and 13, I would have approximately 3.5. The square root of 13 is just a little bit bigger than halfway, so I'm going to go ahead and say 3.6. And if my goal is to estimate, then I'm done. I'm going to be content with 3.6 and move on with my life. Now, there is option 2. Option 2 is honestly the same concept as option 1. It just is a little bit more mathy. So watch what we're going to do. I've taken my original image and cleaned it up. I still found the bookends, the square root of 9 on the low end and the square root of 16 on the upper end. This is still equal to 3 and still equal to 4. No surprise here, this is still going to be 3 point something. The only difference is here, I'm going to count where my number is compared to the total number of values I have to work with. So from 9 to 13, 1, 2, 3, 4, or 13 minus 9 is 3, and 4 what's? Well, 1, 2, 3 more gaps. That makes 7 total gaps, so 3 and 4 sevenths. Put that into, well, it sounds silly to say put it into a calculator because the whole point is to not use a calculator, so do a little long division. You're going to get a 0, no surprise there. The next digit is really what we're after. 7 goes into 40 approximately 5 times. So what that does tell me is that the 6 over here is suspect, but watch what you have here. When you subtract, you get a 5. You bring the 0 down, you remember this. 7 goes into 59 times. So look at that. 0.59 rounds up to 0.6. So I'm still ultimately happy with 3.6. What we did here today was estimate irrationals. We did not compute or convert them, we simply estimated them. And here are 2 solid options for estimating. This will work to a lesser degree on cubic roots as well, with the concepts being the same, the estimation being the same, and your math teachers being just as upset if this is the strategy that you use to calculate an irrational. Estimating, they should probably be okay with this.